taking a look at our kind of our slowed down week here, we said that we're going to do a few notes today. What we learned today, you're going to have a quiz on Friday, so it's a little bit of a tough turnaround, but we're going to be okay with it. And then tomorrow we're going to talk about how to balance equations, and then you're going to have that quiz will be on Monday, okay? So you have your periodic table in front of you. Today we're going to use it for more than just names. Hopefully you guys are getting really good at finding different elements on there, because now you're going to need to be getting their masses, okay? So this is called formula weight and percent composition. I'm going to try to have you write as little as possible, and you're just going to write one example, because more than anything, I just want you guys practicing. Okay, I got a practice worksheet for you. So as soon as you write formula weight percent composition, I will go ahead and just put your pencil down, relax. There is a skill that I think you should already know by now, but let's just see and make sure everybody's feeling swell with the same stuff. So in this baking soda, which is NaH or sodium bicarbonate, as you guys probably would like to be able to name here, what elements do I see in here? I see sodium. What other element do you see? Hydrogen, carbon, and oxygen. Now I'd like to know how many you see of each. How many sodiums are in this one? One. And how many hydrogens and carbons and oxygens? 3. That's because this subscript here talks only about the one in front of it. And we've been doing that a lot in this past little unit. All right, let's try this sodium sulfate. What elements do you see? Sodium, sulfur, and oxygen. Very good. How many sodiums? 2. Sulfurs? 1. Very good. And oxygens? 4. Remember that this does not have a subscript around them, so you only have 1. Let's see if we can't take it up a notch here. Strontium nitrate. We see strontium, we see nitrogen, and we see oxygen. How many strontiums do you have? Just 1. Okay, there is no subscript around him or near him. Now, we know that the 2 distributes through, though. So 2 times 1 gives me how many nitrogens? And then how many oxygens? Good. Some people want to add. This, you should know, is a multiplication type thing. So 2 times 3 is 6. All right, make it a little harder. We have aluminum sulfate here. So we have aluminum, sulfur, and oxygen. How many aluminums do you see? 2. Sulfurs? Good. 3 times 1 is going to give me 3. And how many oxygens? 12. So very good. Again, some prerequisite knowledge you guys should have. Let's knock it out. Let's define what formula weight is first. Formula weight. Formula weight is very simply the total mass of the elements in a compound. The total mass of the elements in a compound. So what that means is I'm going to get my periodic table out and I'm going to add up all of the elements' mass and make a total. The very interesting thing about this is this will be the only number that will never have a unit. Okay? If I say, you're going to eventually like, what's the formula weight of salt? You're going to go 58, and I'm going to say, cool, and I'm not going to say, what unit is it? There are no numbers that I ever like in this class without a number next to it, except for formula weights. Okay? If you technically care, they are called AMU or atomic mass units. They're just so small that we don't even deal with them at this point. I wouldn't write anything else down until I give you a moment here. What you're going to do is to calculate the formula weight, you're going to take the elemental mass, which is just how many you have of each, times the mass. And we're going to use whole numbers off the periodic table. And then you're going to add them all up for the formula weight. So what I would write is a little example for yourself. So let's write example, water, little H2O. With your periodic table near you, the first thing, let's talk about what elements are in water. Hydrogen and oxygen, so let's write those on out for ourselves. Hydrogen, oxygen. How many hydrogens do you see? 2. And how many oxygens do you see? 1. Now it says to get your elemental mass, you say take how many times the mass, and we're going to use a whole number. So hydrogen is going to be times, taking a look at your periodic table, what is the mass of 1 hydrogen? 1. And 2 times 1, don't hurt yourself. 2. Okay, scratch it. I know it was a long snow day break. And then you take a look, and I need to know the mass of each oxygen to multiply that. Now, you want to round it to a whole number. So 15.999 is going to round to 16, and 1 times 16 is 16. So these numbers here, 2 and 16, are the elemental masses. If you care to draw a little line for yourself there. For the formula weight, it says the total mass. So all I'm going to do is I'm going to add 2 and 16 to get 18. It's that snow day math. And that is your complete formula weight. Again, I do not need a unit on that. If it's a formula weight, we're assuming AMU, and we can just leave it at that. Okay, does that make sense? It will get a little more challenging. Don't think you need to write this. I'm probably just going to skip a couple examples here really fast going through for you here. Let's just do these. For instance, if you had this mercury here, 2 oxide, I see 1 mercury, 1 oxygen, and I'm going to add them up. These are the elemental masses. That's going to be the formula weight. Sodium sulfate, I see sodium, 2 of them at 23 apiece, gives me 46. 1 sulfur at 32 apiece, and then 4 oxygens, 4 times 16, and then what I'm going to do is I'm going to add them up. So the formula weight of sodium sulfate is 142. And again, it can get, like we did on our first examples here, 1 strontium, if you look up the mass, it's 88. I see 2 nitrogens at 14 apiece, that's going to give me 28. And then I see 6 oxygens at 16 apiece, that's going to give me 96. You add them all up, formula weight. Okay? Now, the next skill we're going to do here is, I want you to write it right beneath, but we're going to come back to this example here. We're going to come back to this example. We're still going to write some stuff here. The misconception is when you look at water, you say, hey, water must be 66.66% hydrogen and then only, 33.3% oxygen because of the numbers, and that's not true. Look at how different these masses are. So if I wanted to know what percent of water is actually hydrogen and what percent of water is actually oxygen, you do what's called a percent composition. You guys know the math for this. If let's pretend this quiz was out of 18 and you only got 2 of them right, hopefully you did better than that. How would you know what your percentage was if you got a 2 out of 18? Divide it and multiply by 100, right? So you guys know how to do percents. You already have this in your head. So let's just talk about it. Percent composition is the mass percent of each element in a compound. The mass percent of each element in a compound. Mass percent of each element in a compound. There is a little formula if you would like to write it. Again, I think it's kind of self-explanatory, but we can do it. You do the elemental mass, which we just figured out how to do, over the formula weight times 100. And we're going to go back to this example you already had. Elemental mass over the formula weight times 100, and then we're going to take a look at the example you just did. Fire calculator, get out the periodic table, running down a few of these out. The quiz of this is going to be on Tuesday. It's going to be super simple. All right, so let's finish up this water one together, shall we? I want to know what percent by mass of water is hydrogen. So I take my elemental mass and I divide it by the total and multiply it by 100. So I'm going to do 2 divided by 18 times 100. It's 11.1% hydrogen by mass. And then I'm going to do my next one. Let's pretend I got a 16 out of 18 on a quiz. I'm going to do 16 divided by 18. And I get 88.8% oxygen. Now, when you take this quiz on Friday, it's going to be very nice because you'll be able to immediately tell me if you are correct or not within a margin of error. If I add 11.1 and 88.8%, do I get exactly 100%? No. And let's talk about why. We've already rounded off the periodic table, so you might not calculate it back out to 100%. But it has got to be pretty darn close. If you add these two together and you get like 68%, you're like, oh, rounding. No, okay? So as long as you, and it might be slightly over 100, it might be slightly beneath 100, but you can always check yourself. If you add up all your percentages, you don't get close to 100, you've done something wrong. Okay, so let's put this worksheet that I just gave you right in front of you. Let's do a couple. I'm going to do the first one with you if you would like. They get a little bit easier, and then they start off getting a little bit harder after that. All right, so first step, I figure out what elements I have, and I figure out how many I have of them. What elements do you see in this copper 2 bromide? Copper and bromine. How many coppers do you have? 1. How many bromines do you have? 2. Let's dust off that periodic table. What is the mass of 1 copper rounded? 64. 1 times 64 is 64. What's the mass of 1 bromine rounded? Good job. 80. 2 times 80 is 160. Life is good. I'm going to add those up, and I'm going to get 224. This number is going to be extremely, you are going to calculate these until the cows come home. You're going to be doing this on the final exam, so this doesn't go anywhere. Put that number right up here. This is the formula weight. And it says, please also tell me the percent composition of all these elements. How do I figure out what percentage is copper? I'm going to do 64 divided by 224 times 100. And I'm going to do 160 divided by 224 times 100. And then I get my percentages. The hard part here is just knowing which elements you have. In 2, what elements do I have in 2? Sodium, oxygen, and hydrogen. They are no longer going to act as a polyatomic ion when we're talking about mass. I got to go every single element. Down here I see nitrogen, hydrogen, and sulfur. Okay, so this quiz is going to be on Friday. I want you to knock out a few here, making sure you feel good. I'm bringing around a key, and we will see how we do here. Very good today, guys.